All right, so we're gonna do 10. I think I gave you 10c. So 10c, you have y is equal to -4. So if I'm doing one of these problems, A would be, I'm gonna use the negative value just to avoid any confusion. But it's okay if you just use 4, you'll just flip the graph around. And c is equal to -pi/2. So the first step is to find the period, which is 2 pi over b, which is 2 pi. The phase shift is -c over b, which is minus pi/2 over 1, which is pi/2. So basically, I'm working in the interval, the phase shift, and the phase shift plus the period. So we'll plot the graph. And I'm going to say 1 cycle or 1 period over the interval, this interval here. So where do we start? We start at pi/2, and where do we end? Well, so the start is pi/2, we end at pi/2. So phi plus t is pi/2 plus 2 pi, which is 5 pi/2. So we have here 5 pi/2. So are we good so far? Excuse me. Any questions at this point? So we're ready to basically plot this graph. And we're going to start here at pi/2. We're going to end at 5 pi/2. So the midpoint here, if you add 1/2 plus 5/2, it'll be 6/2, which is 3 pi. So this is 3 pi/2. And if you find the midpoint, so 6 pi/2 is 3 pi, you divide by 2. And if you find a midpoint between pi/2 and 3 pi/2, you add these two, you'll get 4 pi/2, which is 2 pi. 2 pi divided by pi would be, sorry, 2 pi divided by 2 is pi. And then if you add these two, you'll get 8 pi/2, which is 4 pi. 4 pi divided by 2 would be 2 pi. What is the height of this graph, anyone?
Yeah.
Very good. So the highest I can go is 4. Now, if you think back, the sine graph looks like this. The negative of that will be like this. So that's what I'm rooting for. I use a different color. So right here, it's this point, and that point. And in terms, this is -4, this is 4. So at -4, you're going to be yay high, and at 2 pi, you're going to be at 4. So if I'm going to draw the graph, you want to do a decent job on the graph. And this is what it is. So for all intents and purposes, this is what we're asking you for. This is the local max. This is at 2 pi, 4. You have to label that. This is the local min. Excuse me. This is pi, -4. So pi, -4. And the intercepts, this would be pi/2, 0. This would be 3 pi/2, 0. And this would be 5 pi/2, 0. So this would be your answer. Do you have any questions on this? So this was problem 10C. Please let me know if you have any questions. So may I go to the next page? If you have questions, feel free to ask. If not, I'll go to the next page. So I seem to be missing a lot of students today, or maybe they're coming in. All right. So I'm going to go to the next page. Let me know if I need to come back. I'm totally cool with that. So we're going to do 11. And what was 11 now? 11C, right? I believe. So we shall do C. And so they ask you for all find. All the keyword here is exact solutions. So that calculator business wouldn't really work. Excuse me. So we have tan square x minus tan x equals 0. If you factor out tan x, it'll be tan x into tan x minus 1 equals 0. And if you split this in two, you have tangent x is 0 and tangent x is 1. So we're going to get the reference angle. What is their reference angles here? For tan x, what is it? Tan x equals 0. What tan of what will give you 0? Anyone?
0.
180.
Very good. Go ahead, Lewis. What was that?
Yeah, tangents will be in 0 and 180.
So I'm only asking for the reference. So I would agree with the suggestion of 0. And here with tan x equals 1, what's the reference angle?
45.
45, and you're absolutely correct. And I'll write it in radians, of course. So you can either put 0 degrees and 45, but don't forget to convert into radians, because that's what we're looking for. So Lewis was kind of solving the whole problem, which is cool, but let's do one thing at a time. So tangent is positive in the first quadrant and in the third quadrant. Is that feasible for you guys? Is that correct? Excuse me. So are we good so far? All right. And you know, that's like the main thing to look at. So what's going to happen here? This is the horizontal angle, or as Lewis said, well, why not think about pi also? Well, so I'm only doing this part first. So x is 0 plus n pi, or x is equal to pi plus n pi. Either one would work. It turns out they're one and the same, but I'm okay if you write two different things. And this one, you know, if you factor out the pi, it's n plus 1 pi. So these two things are the same. It's just a shift. But I will write both, as I said. Don't want to cause any confusion. But officially, you can combine these and write it as n pi. You know, if n is 0 here, this would be 0 pi. If n is 1 here, it'll be 1 pi. If n is 0 in the other one, it's 1 pi. So they both give you the same values. They're just off by 1. And for pi over 4, so, you know, how does one work this out? Right? So what's the story here? How do we work with this one? So 45, which quadrants are we in? Anyone? So Q1 and where else?
Q3.
Q3. So what's going to happen here in Q1? It will be pi over 4 plus n pi. And in Q0, so if we do this of 45, let me just draw this different picture. Sorry about that. Let me erase some of what I wrote here. Should use a different picture. So I'm gonna redraw this. That's all. So in this case, all students take calculus. It will be in here and in here. So this is 45 and this is 45. So x is pi over 4, or x is pi plus pi over 4, which is 5 pi over 4. And so the answer will be x equals pi over 4 plus n pi, or x equals 5 pi over 4 plus n pi. Here again, these two things are the same. You know, if n is 0, if n is 1, you'll get 5 pi over 4, and if n is 0 in here, you'll get 5 pi over 4. They're just off. So what most people do when they write the solution, they'll just say x is n pi, and x is equal to pi over 4 plus n pi. If you write both of them, it's not wrong. It's just that you're being redundant, so to speak. And I wanted you to see a cosine one because we mostly did problems with sines and cosines. But even though, sorry, I wanted you to see a tangent one, but we mostly did problems with sines and cosines. I would recommend that you go over the ones which was done in class with the sines and cosines. It's highly likely that you'll get one of those on your finals. So it's important, you know, that you stay on top of that. All right, any pressing questions or comments? Then I will go to the next page in a moment. So in problem 12, in 1998, you had a population of 10,000 and it's exponential decay at 1.5% per year. So on the review sheet, the problem is worded poorly. The best way to think of these problems, the first step should be to find the model. So the formula I give you, and I'm going to write P of X, P as in population, is C times B to the X, where B is equal to, well, if this is a decay, what is B equal to in terms of R?
1 minus R.
Nicely done, 1 minus R. And, you know, of course, R would be, so we want to have 1.5 over 100, 0.015. Are we okay with that? So P of X is equal to, and C is always the initial amount or start value. And so what are we starting with? 10,000, right? So C is 10,000. So we'll have 10,000. B is 1 minus R, it's 1 minus 0.015 raised. Let me just write this a little bit better than this. All right, so P of X is equal to 10,000, 1 minus 0.015 to the X. And the important thing to note, this is X is 0 here. I would recommend, since we're dealing with time, right? So instead of X, I will write T. And that's just to make it more realistic. But it's the same formula I'm using, so T is equal to 0 here. So the first order of business is to find this equation. When you're doing problems like this, I should point out, you basically have two different models. One of them is the discrete model, and the other one is the exponential, but you would need to work that out, 0.085. And so it's 1 minus 0.015 raised to what power? 5, right? So can someone work this out for me and tell me what value you got? Anyone? What is the value?
9,272.
Yes, excellent. And so I want you guys to pay attention to this because I don't want you to mess up on this. So I like the fact that Miguel gave me 9272.16. I just want to make, and it helps me to make this comment so that I don't want you to do it tomorrow. If they're doing a population of something living, we can't have like 0.16 of a person. It's not realistic. So either round up or down. So it's an estimate. So I am okay if you round up or down, even though this is not close to, for all intents and purposes, it's closer to 9,272. So that would be the best way to do it. But that decimal is not going to sit well because technically you can't have a fraction of a person, not as far as we know. So we want to avoid those scenarios. So that's good job for those of you who calculated this. And if you use, so I'll repeat again, this is what's called the discrete model. So on the exam, we will say use the discrete model just so you know what I'm talking about. It helps because most of the online apps use the other one. And so we would like you to do your own work. Anyways, so in part B, what did they ask us? In what year will there be half of the population left? So if we start with 10,000, so I basically have to find T when 10,000 becomes 5,000. When P of T is 5,000. Is that clear? So it would be 5,000 is equal to 10,000 times 1 minus 0.015 raised to the T. So if you divide both sides by 10,000, this will give you 1/2 equals to 1 minus 0.015 to the T. The way to solve this is to do what to both sides? Does anyone remember?
Log.
Yes, very good. So we'll take log of both sides. And this is 1 minus 0.015 to the T. This is log of 1/2, which is T log of 1 minus 0.015. Oops, oh no. You just clean that up. So it's T times ln 1 minus 0.015. And T, of course, would be log of 1/2 divided by log of 1 minus 0.015. And so what is T equal to if you work this out? Anyone? Well, what is T equal to? That's not answering my question. 45.862. So if you do this, T would be 45.862. So, so that seems to be what we're looking at, 45.862. So in other words, if 1998 is time T equals 0, note we're not rounding up here. We want to know what year we're in. So you will just need to add 45 to 1998. And so the year would be 1998 plus 45, which is 2043. And that would be it. Because in the year 2043, you could be like 0.8 of that year into the year at some point. So notice, technically I'm going down here by 1. When you get these kinds of problems, all the problems go in the same manner, except one aspect that you have to pay attention to is if it's a growth, what would you do? Instead of 1 minus R, what would you put? Anyone? Right. And I suspect the next problem would be that, so we'll do that also, number 13. I will wait. Let me know when you guys are good with copying, and then I'll go to the next page. All right, so problem. Go ahead, what was that? I'm sorry.
Professor, in that case, I got 45.86. We can do around 46, not 45, or we have to leave at 45. Clear year, 2 years.
Because it wouldn't like if you add 2.5 to this, it wouldn't say 2023.5, it would just say 2023, right?
Yes.
So that's the point I was making with that. So if you go back to the previous problem right here, if we got 45.9, let's say 45.9, right? And if you add 1998 to it, you'll get 2043.9. Do we read the year as 2043.9 or just 2043? It was just 2043, right? You see the 0.9 is part of the year, but because you didn't complete it, you can't go to the higher number. So if you actually go to the higher number, then your answer will be off by 1 year.
Okay.
Right? So does it make sense why, even though I know it's instinctive to round up, but think about how we do years, right? Like if we take 2021 and 2.5 years from now, we don't go around telling people it's 2023.5. We'll just say it's 2023, and that was the point I was trying to make on that. So hopefully it's clearer. Is that good?
Yes, thank you.
All right, cool. So all right, so I'm gonna go to my new page, and I think we're up to problem 13, right? All right, so in problem 13, they have in 2003, the population is 80,000. So the initial amount C is 80,000, and the rate is 4%, which is 4 over 100, which is 0.04. This is 4% per year. And what is it doing? Is it growing or not? According to the problem, it's growth. So the model is P of t equals to C times B raised to the t, where B is 1 plus R. Why 1 plus R? Because B is a growth. So P of t is the initial amount, 80,000, times 1.0. I'm going to write a little bit below there. So P of t is 80,000 times 1.04 to the t. That's the model. And so before I proceed, that's what I need. Are we good so far? So part A asks you, what is the population in 2013? Well, consistent with what we were doing, this would be t equals to 0. So this would be t equals to what? Very good, 10. And so in other words, the problem is asking us to find P of 10, which is 80,000 times 1.04 raised to the power 10. And can you guys work this out and tell me what you got? And then we'll figure out if it's accurate enough. So any ideas? Did I write something wrong?
Yeah, about the year is in the 2015.
Oh, is that 2015? All right, thank you. Okay, so let's say if it was 2013, then this would have been the answer, but since also it's going to be way bigger. Wow. Thank you. And let me correct that because we want a 2015. So t is equal to, erase this. So t is 12, as you guys pointed out, and this will be 12. All right, so back to the drawing board. What is the population now? Okay, so it's so this, all right, yeah, 120. Oh wow, so 128,083, I would say, approximately. If you go 82, depending on how you round, it's not a big deal. It's an estimate, anyways. So is this good with everyone? There's still a part B. What did they ask us for part B? In what year will the population triple? When does P of T triple? So if you start with 80,000, triple means 3 times that amount. So you want to find T when P of T is equal to 240,000. How did I get 240 again? I just multiply this by 3, right? So if we solve this thing, P of T is 240,000 equals to 80,000, 1.04 to the T. And this is identical to what we did just now. So if we divide both sides by 80,000, what's nice about this, we'll end up with 3 equals 1.04 raised to the T. And then if we take log of both sides as before, we have log of 1.04 raised to the T. And if you move the T in front, you have log 3 is equal to T log of 1.04. And T is log 3 divided by log of 1.04. And what is this T equal to? So you guys got 28.011. All right. So if you're getting T to be 28.011, and what year did we start? 2000 what? 2003 plus 28 is 2031. So notice I can't put a year as 2031.011, obviously. And so we went over that discussion, and so this is the year. Yes, Shumi, go ahead. Oh, sure, yeah. I just wanted to finish the problem on that page.
Yeah.
Sorry about that.
So for the T equal 12, how did you get 12?
So 2003 is at time T equals 0, right? And 2015 would be what? It would be 2003, subtract 2003 from 2015, and you'll get 12.
So you say you subtract 2000. Okay.
But does it make sense to you if
Yes.
2003 is considered 0, like 2004 going to be 1, 2005 will be 2, and so on?
Okay. And last time, because on the exam, it was showing like it's 1998. So whenever it's showing the number, I'm going to do always subtract this both number, the present and the previous year, right?
Yeah, I can go back to that one. I didn't erase it. So yeah, so when it comes to this one, right? We had 1998 here, which is 0.
Yes.
Yeah.
But they didn't tell us the year here, which would have been 5 years, 2003. They kind of gave you that the year was 5 in the column, so I didn't have to work it out. But if they had asked you in the year 2003 what was the amount, then you would have subtracted 2003 from 1998 and get 5. But in this problem, if you read it, they didn't ask us. I mean, they were more kinder in that one, in that they give it to you up front.
Okay, thank you.
You're welcome. Are you guys done with this? Should I wait? All right, so I'm gonna go to the next page. Let me know. So problem 14, and we have to find the inverse of some function, which we shall do next. So 14C, I believe. So in C, we have y is equal to 2 over 8x plus 5. Can someone tell me what I need to do here?
Switch x and y.
Very good, yeah. So we'll switch the roles. So it's 2 over 8y plus 5. And if you cross multiply, this will give me x times 8y plus 5 equals to 2. Are we good? Then if you distribute into this, you'll have 8xy plus 5x is equal to 2. And the goal is to, so first we switch rows for x and y. And then the next step is to solve for y. And so if you subtract 5x from both sides, you'll end up with 8xy equals to 2 minus 5x. And if you divide both sides by 8x, you'll end up with y equals 2 minus 5x over 8x. And so ultimately, the inverse function, f inverse of x, is 2 minus 5x over 8x. Let me know if there are any questions on this. I would totally accept this as an answer. If you want to simplify a little bit more, you can write this. It's not necessary. And in this case, this would be 1 over 4x. The x's will cancel, it would be minus 5 over 8. So you can also write it, oops. You can also write it that way, but it's not necessary. I would totally accept this. I didn't ask in this problem, but it's understood that as far as the domain of this inverse is concerned, x can't be 0, because then you're dividing by x, and that's an issue. And when it goes to the original function, the domain x cannot be minus 5 over 8, because that would make the denominator 0. And that's an issue for us. So we want to avoid that. If you have any questions on this, please let me know. I can, yeah. So I am gonna go to the next page. And so we're also gonna do part D. Excuse me. So we have y equals to x minus 1 over x plus 2. So the first step is to switch rows for x and y. So we'll have x is equal to y minus 1, y plus 2. And then if you cross multiply, you'll have x times y plus 2 equals to y minus 1. So notice, even though they gave us y equals, I wrote it as y over 1. And the reason for that is because it's easier to see what you're doing with cross products or cross multiplication. Now, if I distribute, this will be xy plus 2x equals to y minus 1. And So I need to move all the y's on one side and the x's on the other side. So suppose I subtract y from both sides. So this would be xy minus y plus 2x equals to -1. I'm going to line them up a little bit better. Sorry about that. So where the equal sign is, these y and -y cancel out. I'll have -1 here. This is xy plus 2x minus y. I want to write it that way you're seeing it. Then the next order of business would be to subtract 2x from both sides. And if we do so, we'll have xy minus y equals to -1 minus 2x. So hopefully that's clear to everyone up to this point. If it isn't, you can ask away and we'll figure out things. So what's going to happen here? The next step, you would want to factor out y. And so you'll have y times x minus 1 equals to -1 minus 2x. If you divide both sides by x minus 1, then you will end up with the inverse, or y equals -1 minus 2x over x minus 1. Now, this is absolutely correct. There's nothing wrong with that. I have two negative signs at the top. So if I multiply top and bottom by -1, so I'm going to put an R here. -1 times -1 is 1. -1 times -2x is plus 2x. -1 times x is -x. -1 times -1 is plus 1. And this would be 2x plus 1. Let me repeat that. That would be 2x plus 1 over 1 minus x. I'll reiterate again. I'm totally okay with you writing the inverse as this. So you have the option of writing either one. Let me just change the color. So we've shown that f inverse of x is either -1 minus 2x over x minus 1 or 2x plus 1 over 1 minus x. And you will get full points on either one. Let me know if that's clear or if I didn't answer your questions, feel free. No problem, you're welcome. So on the in the class test, I tested you on arithmetic. So, it's a good chance you'll get a geometric on your finals. So that's something you would want to be prepared for. May I go to the next page? All right, so thank you. So what is it? Number 16. So they want us to find the exact sum of the geometric sequences below. And more importantly, infinite. So here's the thing. The sum to infinity is equal to a over 1 minus r, providing the absolute r is less than 1. So that's an important thing, very, very, very important. So we have to keep that in mind. So r can be greater than 1, or r can be less than -1. So it's infinite if r is greater than -1, or sorry, r is greater than 1 or r is less than -1. So it can either be plus or minus infinity, depending on the situation. So if we're summing a bunch of negative terms, it will go to minus infinity. And if we're summing a bunch of positive terms, it'll go to plus infinity, or eventually positive. Now, to be honest, I mean, as a matter of completeness, I put this in right here. But for the purposes of this course, this is usually what you run into. And so as I said, I just put that in as a matter of completeness. So let's see, they give us like a few parts. So we'll work on this and try to figure out what's happening. So let's look at part B, for example. So we have 32 minus 16, 8, and minus r. So what is a in this problem? Anyone?
32.
Very good. What is r in this problem? How do you find it? Tell me.
2 divided 1.5.
I disagree with you.
Negative 16 divided by 32.
And what would that give you? It'll be negative a half. I think you told me 1/2. You got to be careful. So the radius, the r is this, which is clearly less than. So I'll just say absolute r is less than 1. So what does that tell me? I can apply my formula, which is a over 1 minus r, which is 32 over 1 minus a half, which is 32 over 1 plus a half, 32 over 1.5 or 3 halves. So this is 32 divided by 3 halves. What does that mean? It means 32 over 1 times 2 over 3, which is 64 over 3. And we want exact answer, so please don't simplify. Further, that is sufficient. So it's not an issue once you set that up properly. May I go to the next page? I would also like to do part D. And in D, you have negative 54, negative 18, negative 6, negative 2, and it goes on and on. So what is A in this problem? Anyone?
Negative 54.
Excellent. How do I find R?
Dividing the second term to the first.
Very good. So it's negative 18 over negative 54. And what would you get with this? 1 over 3, right? Is that clear? So clearly, absolute R is 1/3, which is less than 1. So I can apply the formula, which is A over 1 minus R, which is negative 54 over 1 minus 1/3, negative 54 over 2/3, negative 54 over 1 divided by 2/3, negative 54 over 1 times 3 over 2. 2 into negative 54 is negative 27 times 3. Negative 81 would be my answer. All right. So it's useful to do all the steps, be very, very careful, and you should be perfectly fine. Right? Yes, I can do A. 1/2 minus 1/4, 1/8, and so on. What is A equal to in this problem?
1/2.
Very good. How do I find R? What do I have to do to find R? Anyone?
Negative 1/4 divided 1.5. I mean 1 over.
Very good. Yeah. And this would be negative 1 over 4 times 2 over 1, which is negative 2 over 4, which is equal to negative 1/2. So R is negative 1/2. The absolute value of R is 1/2, which is less than 1. And that tells me that S infinity is A over 1 minus R. So this is A, which is 1/2 over 1 minus 1/2. which is 1/2 over 1/2. Well, I could have set this up as a half divided by a half. Since they're identical, this would give me 1, right? So we would get solid 1. Is that correct? Is everyone agreeable with that? Okay, so what should I put, Li Shang? Yes, and so notice, so just be careful. And there was a point I was trying to make here because I see it happen a lot on tests. So this is minus a half, right? So this is where, one has to be really careful. So this would be oops, want to put a different color here. And so this would be 1 minus a half, which is a half over 1 plus a half, which is 1/2 over 3/2. And here's where you do division, which is 1/2 times 2/3. And this would be 1 over 3 when these guys cancel out. Now, by the way, if this was a plus a half, then what I was doing there would have been correct. But I wanted to make sure that you guys are on top of the signs. So this would be 1/3. So are we good now? No tricks. Should be straightforward. All right. If we're done with this, may I go to the next page? Yeah, no worries. All right. So we are going to do 17. So when you're doing a problem with the binomial theorem, write out the expression. The first step is to figure out what A is and B is. So A is 2x here, B is minus y over 2, and C is equal to 8. From my experience grading this for students on the finals, oftentimes people will leave out the negative sign, and then it messes the whole thing up. So you want to really avoid that. So 2x minus y over 2 to the 8. Well, A happens to be 2x, n is 8, plus 8, choose 1, A to the, A is 2x to the 7, and B is minus y over 2, plus 8, choose 2, 2x to the 6, and this is minus y over 2 square. So there's one more I have to do. 8, choose 3, 2x to the 8 minus 3 is 5th, and this would be minus y over 2 cubed, plus, and so on. So what is 2 raised to the power 8? Anyone? So if you take out your calculator and do this, you'll get 256 x to the 8. 8 choose 1 is 8 times 2 to the 7. So the 2 to the 7 is 128 x to the 7th times minus y over 2. So it's getting bigger. What is 8 choose 2? Anyone? Does anyone know what that is? Well, here you would use your calculator, right? And what is 2 to the 6? That would be 64. All right, so you agree with my 28. This is 64, x to the 6, and this is y squared over 4. So this is 28. What is 8 choose 3? Anyone? Is this 56? Very good. So it's 56. 2 to the 5th is 32. X to the 5th. And this is minus y cubed over 8. So it involves a lot of steps, and you have to keep track of what you're plugging in. And I'm not done yet. I mean, it's pretty long. So it's 256, x to the 8. This is negative. And I have to multiply these terms to see what they'll give me. Excuse me. So as I said, we'll have to multiply these guys. And so if I simplify here, I'm getting 512 x to the 7y. And then the next term, so 4 into 64 is 16. 16 times 28 is 448. 448 x to the 6th y square plus, and the last one looks kind of messy. So 8 into 32 is 4. All right, so that's not so bad. And there's a negative sign here, so I have to honor that. So 56 times negative 4, 224, 224, x to the 5th, y cubed. And there are more terms. So technically, if you do this, you should put 3 dots, right? It's just that you don't have to tell us what those 3 terms are, or they're not 3 terms, what the remaining terms are. But it doesn't mean that you shouldn't put the 3 dots. So since this is raised to the 8th power, how many terms do you think you would have gotten? How many terms? If we're raising this to the 8th power, very nice. You will get 9. There's always one more. So that's a good thing to keep in mind. So that's always recommended. That, as I indicated, you should always keep that in mind in case we ask you to put the whole spiel. And then, you'll have your work cut out in that regards. So that is 17, part A. Part B asks you to find the 7th term in the above expansion. Now, I just want to make a comment, and it shouldn't trouble you at all with this, but I just want to say, when we asked you for the 8 terms, the first 4, I treated this as A and I treated this as B, and then I did my thing. But I also want to say that there's nothing wrong if you treated this term, if you want to call this term A and this one B, that would have also been fine, and you would have gotten a different answer. So this problem that we just did right here, this has a different answer. It just means we didn't say which terms you have to give us. So technically, there are 2 answers. Either you'll have 256 x to the 8th as the first term, or you can have y to the 8th over 256 if you expand it here. And it's the same thing. If someone asks to find the 7th term in the above expansion, if you count in this direction, 1, 2, 3, 4, 5, 6, 7, then you give me the one on the right. But if you count in the opposite direction, then this would be the answer. Because the way the problem is stated, it's poorly written, actually. When I say it's poorly written, it allows for more than one answer. So, there is that option. But if you don't overthink it, basically, if you apply it straight up, and I believe that's the intention, you'll have A as this and B as that. But the way the problem is stated is not quite right. Like on my test, if I ask you to give me the first 4 terms, for example, I would say with x to the 8th in it or something, so that you can start with this as your A. So the convention we'll use in this class is we'll always start with this one as A and this is B. But there's no rule that forbids you from switching them around the way the problem is stated, I should point out. And I just wanted to make that point. So I gave you a formula yesterday for the kth term. And I'm not asking you to memorize it. To be honest, if you were taking this class in a face-to-face setting, then we would have most certainly had you memorize it, because that's not a formula that we give, or we don't give you a formula sheet on that particular score. So oftentimes when you run into a problem like that, it's up to you to remember what the formula looks like. If you don't know what it is, then in some sense, you'll be stuck, like you wouldn't know what to do, and you wouldn't be able to, find it, and that would be an issue. So the hardest thing here is the kth term is n choose k minus 1. Notice I go one less. A raised to the n minus k plus 1. B to the k minus 1. And so, you want to honor this. So in this problem, k is equal to 7. We already know what a is and b is. So I just got to plug it in and n. So the 7th term will be 8. Might use a different color, green maybe. So it'll be 8 choose, k is 7, 7 minus 1 is 6. And what is a? 2x raised to n is 8 minus 7 plus 1. And b happens to be minus y over 2. K happens to be 7, so it's 7 minus 1. What is 8 choose 6, anyone? Okay, so we're getting 28 from that, which I agree with, by the way. So that's 28. And this is 2x. 8 minus 7 is 1. 1 plus 1 is 2. And this is minus y over 2 to the 6th. And so 2 square is 4. So it's 28 times 4 over 2 to the 6th is how much? 64. And this would be x squared, y to the 6th. So I just need to simplify this. What would this simplify to, anyone? So 4 into 64 is 16. And then if you divide top and bottom by 7, you will end up with 7 over 4 x squared y to the 6. And that would be your term. So in some sense, this one is easier than the other because once you know the formula, you just plug it. They're both formula based. But the reason I'm claiming this kind of problem is easier is because how many times do I have to do this calculation? Just once. Here I had to do it 1, 2, 3, 4 times. So, but either way, I think it's pretty straightforward once you substitute into it. So nothing mysterious there. So are we good so far? So let's do problem 18. So let me see how many sheets I have. All right, so we can fit this problem in here. So this is 18. Excuse me. Yes, Shumi, go ahead.
So can you go back, please?
Sure. Let me just write the problem, 6 to the minus x. Give me 1 minute, please.
Sure.
And here we go.
Can you explain me the last part? 208 parenthesis 4 x squared y over 4 to the 6 divided by 64. Then you get the answer. This last part.
So are you with me? Let me just highlight this. Are you with me so far here?
Yeah, I need
Well, I said it. Let me say it back again. How many times does 4 go into 64? It's 16 times, right?
Yes.
So you have 28 over 16.
Okay.
And 7 goes, so 4 goes into 16 4 times, and it goes into 28 7 times. So we have 28 times 4 over 64. 4 ones, 4 16. So we have 28 over 16. And 4 into 16 is 4. 4 into 28 is 7. So you'll get 7 over 4.
Okay.
If you square, well, okay, I mean, you got up to here, and that's how I got that. Is that good?
Yes.
Okay. So we have to solve. Is there another question? I don't want to go before.
No, that's good. Thank you.
Okay, no worries. How do we start this? Anyone? How do we start this problem? I mean, I know most of you know how to do it, but tell me anyways. Yeah, you would take log of both sides, and we'll do ln of 6 to the minus x is equal to ln 2 to the 4x plus 5. And if I bring that in front, I'll have minus x ln 6. And if I bring this in front, I'll have 4x plus 5 ln 2. So we have minus x ln 6, and I have to distribute here. So this times that, and this times that. And so what we'll have 4x times, I'm going to put the log 2 here and put the x by itself. And this is 5 ln 2. So the idea is to solve for x. And we have a few options. So suppose I subtract, maybe I should use a different color here. So if we subtract 4 log 2x, because I want to keep the x's on the same side, what we'll end up with is minus x log 6 minus 4 log 2 times x is equal to 5 log of 2. Now, next step is extremely important. You have to factor out x. And so we have minus log 6 minus 4 log 2, which is equal to 5 log of 2. So before I proceed, make sure we're good up to this point. Don't want to do any sudden moves. So the next phase is to divide both sides by minus log 6 minus 4 log 2 minus log 6 minus 4 log 2. And we're effectively done here. It's 5 log 2 over minus log 6 minus 4 log 2. And I'll do the same. So this is good up to this point. I will do the same trick I used earlier where I multiply top and bottom by -1. So this would be negative 5 log of 2. And negative times negative log 6 is plus log 6. And negative times negative 4 log 2 is plus 4 log 2. And so this is your answer. So x is equal to minus 5 log of 2 over log 6 plus 4 log 2. If for an argument's sake, I had done the following, not use ln, which is the natural logs, and if I had used log to the base 10, the answer would be identical to this, looking, except there would be log log for log to the base 10, log and log. And when you punch this in your calculator with the natural logs or the base 10 logs, they'll still give you the same answer. So normally what's been happening when you get a problem like this on the test, they want you to leave it like this. So I would recommend that you do. You don't have to simplify further, right? So you don't have to punch it in your calculator for all intents and purposes.